Hello, I would like to welcome you to our ink test laboratory. My name is Robin and I work in the group of optical test methods and nanosensors. I will show you today our systems and devices which we are using in the development of new inks. At first, I will show you our self-developed ink test bench. My colleague Peter will start now the printing process. At first, the robot moves to the metal sheet and moves a metal sheet under the printer. There, the robot will wait until the marking now is completely applied. We take then a fluorescence picture and also a color picture for later elevations. I will take this metal sheet to my colleague and he will put it into the oven. We can do here tests over several weeks under different conditions. For example, we have here integrated heater, and we do also short experiments here in our test bench. So we test our inks carefully before we go to the industry. Currently, we have here a drop-on-demand printer integrated in this test bench. It has 16 nozzles and the whole printing system is parted into the printhead here and also on an ink supply over here and a cleaner station. If we start with the ink supply, the yellow ink is continuously pumped over the printhead at circa 0.9 bar. As soon as the printing is started, a small stamp is pulled off the nozzle place and then a tiny drop comes out of the nozzle plate. So you can see these are the 16 stamps here. In our application, we use this printing system up to a minimum DMC size of 30 millimeters. For pre-test of the inks, we have here our setting station. It's very important that the 16 nozzles are perfectly adjusted. So if we don't set the nozzles correctly, the throttle break off will be not perfect and the printhead will clock within few hours. In addition to set up this printer, it's also important that the ink has a proper gauge of the viscosity. We use this viscometer for our research projects and also the quality assurance. So now we come to the second printer system. We added this continuous inkjet printer to our portfolio because we realized that they are limited to DMC size and also component geometry. For example, we print quite small DMC codes on a metallic surface. We found this system also in food packaging, for example. There is a continuous inkjet over there. You see the line here? These are many drops. This inkjet hits a collection opening, and from there it's pumped back into the ink bottle. As soon as the printing is started, the individual drops are electrical charged to different degrees and then deflected by an electrode. So we can make quite small markings and also bigger ones. For this system, it's very important that the conductivity is also measured and recorded. Furthermore, we measure the surface tension and the particle size distribution, but externally. We have a lot of internal and external partners which are helping us in solve our problems. At the start of our lab tour, we printed in our test bench a metal sheet with a heat-resistant ink, and my colleague Peter put it into the oven. Our oven can heat up to 1600 degrees under atmospheric conditions. If you need other conditions, we have many more ovens in our IKTS family. Now I will take the metal sheet out of the heating . For us, it's very important that the properties are before and after heating the same. So we want to have contrast and also smooth resistant. You see, nothing happened to the DMC code. In addition to printing by hand or with our test bench, we have here our conveyor belt for small series or large products. That was my short presentation here in the lab. I will say thank you for your attention. If you